What is protons plus electrons plus neutrons for a group 5 element with a mass number 3 times the number of its protons? 16, 26, 31, or 38? First, let's highlight the pieces of information we know and emphasize that the green pluses are protons, blank red balls are neutrons, and minuses are electrons. And it turns out that this is more information that we can use. We can count up the number of electrons, but not the clump of protons and neutrons because it's too cramped. Our atom has 10 electrons. And with that, we figured out one piece of the puzzle already. P plus E plus N becomes P plus 10 plus N. Next, let's single in on the fact that our atom of interest is a group 5 element, meaning it is an element that belongs to this column right here in the periodic table. In fact, group number the element belongs to also tells us how many valence electrons the atom has. For example, group 2 elements have 2 valence electrons, and in this case, group 5 elements have 5 valence electrons. But hold on a second. Our atom clearly has 8 valence electrons, not 5. So what gives? And how can we use this discrepancy to find more information about this element? Well, it turns out that this group number equals valence number relationship is only true if our element has a neutral charge. In other words, a net charge of 0. Instead, with 8 valence electrons, that's 3 extra electrons. So it's going to have a net charge of -3. Since net charge is like a soccer game of team proton versus team electron, a net charge of -3 means that team electron scored 3 more goals than team proton. In other words, our atom of interest has 3 more electrons than protons. And remember, we've already established that our atom has 10 electrons. So if it has 3 more E than P, it's got 3 less P than E, 7 protons. So we now know 2 of the 3 subatomic particles. There's 7 protons and 10 electrons. That also means that A is wrong, because if protons and electrons already add up to 17, even if there were no neutrons in our atom, we could never have 16 as our sum, because you can't have a negative number of neutrons. The last piece of evidence to use is the fact that mass number is 3p. Mass number, denoted as A, is the sum of protons and neutrons. Writing this more clearly, A equals 3 times p, but how does that help us? Well, if 3 times p and p plus n both equal A, mass number, then they both equal each other. So let's set them equal to each other. And as a reminder, n is the only thing we still need to figure out. So let's use some algebra and set everything equal to n. We get n equals 3p minus p, which means that n equals 2p. In other words, there are 2 times as many neutrons as protons. So since there are 7 protons, there's got to be 14 neutrons because 2 times 7 is 14. And that works out because a mass number of 21 is in fact 3 times 7 protons. So to answer a question of interest, the sum of protons, electrons, and neutrons is 7 plus 10 plus 14 respectively, which corresponds with the correct answer of C, 31. There are 31 protons, electrons, and neutrons in this atom. Be sure to check out the video on how to view and understand net charge as a soccer match between Team Proton and Team Electron.